Okay. So what about the magnetic properties? The magnetic element. So the magnetic elements of the Earth's magnetic field, what are they? So there are three magnetic elements. Of the Earth's magnetic field. Number one, we have the first one is the angle of deviation. Or you can call that the angle of variation. The second one, we can call it the angle of dip, or the angle of inclination. So the third one, we have the vertical and horizontal. Components of the Earth's magnetic field. At a point. So you may be asked, what are the magnetic elements of the Earth's magnetic field? So we say there are three of them, three elements of the Earth's magnetic field. The first one is the angle of deviation, or you can call it the angle of variation. The second one is the angle of dip or inclination. You can either call it the angle of dip or the angle of inclination. And then the third one is the vertical and horizontal components of the Earth's magnetic field at that point. See? So what are they really? So let's define. Okay. So let's define the first one, that is the angle of deviation. The angle of deviation or variation, angle of variation, is the angle between the Earth's geographic meridian, and the Earth's magnetic meridian. So define the angle of deviation as the angle between the Earth's geographic meridian and the Earth's magnetic meridian. For example, if we have the Earth here, this is the Earth's geographic meridian, north-south. Now remember, I told you that the magnetic meridian is such that it's in this way. It's not exactly on the Earth's geographic meridian. So the angle between south-north. So the angle between the Earth's geographic meridian and the Earth's magnetic meridian is what we call the angle of deviation. Deviation or angle of variation. So the magnetic meridian deviates a little bit away from the geographic meridian. So this angle here, something at the center between them, is what we call the angle of deviation or angle of variation. Now what about the angle of dip. You can either call it angle of dip or angle of inclination. What is it really? So we say it is the vertical angle between the magnetic meridian of a bar magnet suspended freely from a thread and the horizontal. Now what we mean by that is this. Let's say we have a bar magnet like this, north, south, and you tie a rope round it, you hold it, or you tie it to rigid support. You see, the magnet doesn't come to rest perfectly horizontally. No, it will always come to rest in such a way that one of its poles will be deep into the ground, so deep towards the earth, such that it makes an angle with the horizontal plane. So this, let's say this is the Earth's magnetic meridian. This is the Earth's magnetic meridian, and this is the horizontal. So the angle between the Earth's magnetic meridian, the angle between the magnetic meridian of the bar magnet and the horizontal is what we call the angle of dip. So this is called the angle of dip, or angle of inclination. It's inclined, it dip, so to speak. So that angle there is what we call the angle of dip. So what about the third one, the third magnetic element of the Earth's magnetic field? So the third element is this, is the horizontal or vertical component of the Earth's magnetic field. So number 3, the horizontal component of the Earth's magnetic field is the magnetic force of the Earth in the horizontal direction. In the horizontal direction. So we define the horizontal component of the Earth's magnetic field as the magnetic force of the Earth in the horizontal direction, and is given by H is equal to B cos theta, where H is the horizontal component and then B is the magnetic flux. Magnetic flux density. And I'm going to be telling you what that is in a moment. And then, so what is magnetic flux density? So the magnetic flux density which is represented by the letter B, is the number of magnetic lines of force passing through an area in a magnetic field. So we define magnetic lines of force B as the number of magnetic lines. Sorry, we define magnetic flux density as the number of magnetic lines of force passing through an area in a magnetic field. You see, so if we have an area, let's say a square inch or a square meter, and we have more magnetic lines of force passing through it, then we say the flux density at that point is high. But if you have fewer, then the flux density at that point is lower. You see. So how would we define the vertical component of the Earth's magnetic field? The vertical component of the Earth's magnetic field is the magnetic force of the Earth in the vertical direction. So define the vertical component of the Earth's magnetic field as the magnetic force of the Earth in the vertical direction. Of course, where V is equal to B sine theta. Of course, V means vertical component of the Earth's magnetic field. Of course, you know what B is. B is the magnetic flux density, which is the number of magnetic lines of force passing through an area in a magnetic field. So in the next video, we're going to be finding the relationship between the horizontal and the vertical components of the Earth's magnetic field.